Comp Review, Assignment 2. Let's begin. Define solar system. Solar system would be the sun and all the objects that are revolving around the sun as a result of gravity. That's a great definition that's down there. You need to remember that you have the star at the center. Solar means star, so star system. Sun for us is our star, and then everything that is going to orbit around, all the planets, all the asteroids, the comets, all that material moving around our star, the sun. Perfect. Name the 4 Jovian planets. That's Jupiter, Saturn, Uranus, and Neptune. Remember that the Jovian planets are going to be the gaseous, Jupiter-like planets. They all have ring systems. They all have multiple moons. Okay, and remember that they're on the outside of the asteroid belt. Remember, the asteroid belt's between Mars and Jupiter, so Mars is the last terrestrial planet. Get on the other side of the asteroid belt and you start with the Jovian planets. Alright, a little bit more here. Name and describe the 3 mechanisms for plate tectonics. Alright, in order it has ridge push, slab pull, and mantle convection. The largest source or driving source mechanism is going to be slab pull, and that happens at a subduction boundary when the weight of the subducting oceanic plate is actually pulling on the rest of the oceanic plate. Why do I emphasize oceanic? Because continental plates don't subduct. Okay, ridge push happens at a divergent plate boundary. This is where 2 plates are moving apart, and think about the mid-ocean ridge. Magma is coming up to the surface. The most magma makes it to Earth's surface, by the way, along the mid-ocean ridge. But it comes up, piles up on top, and then pushes down and outward. In class, I referred to ridge push like the butterfly stretch that you do, or the grunge stretch seated. In gym class, where you push your hands together and your elbows out, up against your knees, and pushes outward. Good. Mantle convection. A lot of people think this is the primary source, but this is what's going on in the mantle as you have hot magma rising, cooling, and sinking. This is actually the weakest of the 3 mechanisms. Good. What is a hot spot? This is going to be a column or chamber of magma that's going to rise up through the plate, not typically along a plate boundary, but rather in the middle of a plate. And as the plate moves over that hot spot, well, now you're going to get a chain of volcanoes. The most famous one that we talk about, of course, is Hawaii. But remember, you also have the exception to the middle of the plate rule, where the hot spot is locked on the mid-ocean ridge in that wonderful place called Iceland, which is why Iceland is so volcanically active. All right. The only 2 planets to have no moons, are Mercury and Venus. Then Earth has 1, then Mars has 2, then Jupiter has 63. Right now we're just getting crazy. If you'd used process of elimination on this question, you would have crossed out Pluto right away, because it has Pluto and Pluto's not a planet. You would cross out Earth because you know that we have the moon, and hopefully you remembered that Jupiter has the 63 moons. The 4 Galilean moons, remember, associated with Jupiter. So that would be Io, Europa, Ganymede, and Callisto. Good. Moving along. 1 full spin of an object around an axis is called a rotation. Right? That's like a top. Think about a top or a dreidel. You spin it, right, when it's making 1 full rotation, right? That's spinning around its axis. It's a revolution when you move around another object. What is the center of our solar system? We'll go back to the first question, right? Center of our solar system would be a star called our sun. So A. Define luminosity. Luminosity is the intensity or the amount of brightness or energy being released from a star. A parsec This is 3.26 light years. And remember that parsecs are important because when we have 10 parsecs, that's the distance at which we would need to place all stars to be able to determine absolute magnitude. Remember, paramagnitude, you just look out and you're like, that star's bright, this one's not so bright. That's just apparent. But if you were to put them all in a line at a set distance, or 10 parsecs, now you could get an absolute comparison, and that's absolute magnitude. Good. What is the rock cycle? Describe a possible path of a rock that begins as igneous rock and becomes each type of rock. So let's begin with the rock cycle is the sequence, the never-ending cycle of how a rock can become any other rock. So igneous rock can become metamorphic rock, can become sedimentary rock, can melt to become magma, and then become igneous rock again. This was proposed or credited to James Hutton, the father of geology, who said the present is the key to the past and is credited with uniformitarianism. Now, let's follow a possible path. So here we have igneous rock will be eroded into sediments, and then those sediments will be compacted and cemented, lithification, shall we, or cementation, to become a sedimentary rock. Now that sedimentary rock can either weather into more sediments and become sedimentary rock, or heat and pressure, due to burial, may cause that sedimentary rock to become a metamorphic rock, or that sedimentary rock could melt, now crystallize or solidify to become an igneous rock. Right? So you guys, if you go back to the diagram and follow all the different hours around, you can see how all the different rocks are connected. Good. List the life cycle of a massive star in order from nebula. So remember, a massive star, these are going to be the huge stars that are going to have a short life in the millions of years, and all stars are starting out as a cloud of interstellar gas and dust called a nebula. It's going to start to compress due to gravity, starts to heat up. This is when we call it a protostar. When fusion begins, we're going to call it a main sequence star, and that's going to be a high mass main sequence star. So here we just called it a massive star. Remember, that's part of the main sequence. It's going to spend the majority of life there, and then when all the hydrogen runs out in the core, it's going to start to compress, causing helium fusion. At this point, it leaves the main sequence, the whole star starts to expand, and you'll become a red supergiant. So massive star, supergiant. Once all of the fusion takes place, you're going to be left with an iron core. That iron core is going to collapse, and bam! Now you're going to get a supernova. Supernova is also when all the other elements are going to form in a star, but that massive display of light is going to either now become a black hole or a neutron star. If it becomes a black hole, it means that its mass is more than 3 times the mass of our sun. Less than that would be a neutron star. Very good. Remember, a black hole, no light can escape, hence it's a black hole. We only know that it's there because of radiation that we can detect, or the fact that its gravitational force can offset objects moving through space. Neutron stars are the densest stars in our solar system, made entirely of neutrons. On to the seasons. List the dates, length of day at the North Pole, latitude of the most direct angle of insolation for each equinox and solstice. So, we start up here with the winter solstice. That's December 21st. That is the shortest day of the year in the northern hemisphere, so the North Pole will receive 0 hours of day. It's complete darkness. The sun's most direct angle of insolation is going to be at the Tropic of Capricorn, 23.5 degrees south latitude. So the majority of the sun's hitting in the southern hemisphere, which is why they like that time of the year and why we are going to experience the colder season up here in the northern hemisphere. Then we move over to March 21st. This is going to be an equinox. Equinox should tell you right away. Equal day and night, so the entire Earth is going to get 12 hours a day, 12 hours of night. The most direct angle of insolation is going to be on the equator, and hence it's an equinox. We'll call that the vernal or spring equinox. June 21st coming up. Going to be the longest day of the year in the northern hemisphere. The North Pole is going to receive 24 hours of day, and the most direct angle of insolation for the sun is going to be on the Tropic of Cancer, 23.5 degrees north latitude. So that's the summer solstice. Remember, if you know your astrological signs, that Cancer begins on June 21st. September 21st. This is going to be the autumnal equinox. 12 hours a day, 12 hours a night. Again, it's an equinox. So where's the most direct angle of insolation? On the equator. And it's equal day and night. Awesome. What's the goal of science? Very simple. To understand the natural world. To understand the natural world. The rest of this definition is great. All right. When does a protostar become a main sequence star? I said it before, I'll say it again. When hydrogen fusion begins. When hydrogen fusion begins in the core. All right, on to topography. This is going to be really important. We spent a lot of time, you've seen it on trimesters, we did labs on this. Expect some good topographic questions. So make sure you understand what you're looking at in front of you. So first off, what are the different elevations? A, 900, right? Look at the contour line. Right next to it, it says 900. B, you're like, wait, is that 800 or 900? If you go from 800, then it's 900, then we label 1,000. So just look at it. B is 900, C is 1,500, and D is going to be 1,000. Right? Not too difficult yet. Now, what is the contour interval of this map? If the map doesn't say what the contour interval is, then you find two contour lines that are labeled, and you count the number of contour lines from one to the next. So if I started over here at 1,000, right? Well, then I'm going to go 1, 2, 3, 4, 5. And now I know the number of contour lines. I go 1,500 minus 1,000. Hopefully y'all can do that in your head. It's 500. Now I'm going to divide 500 by 5. And my contour interval, my CI, should be 100. Next, gradient's a pretty big deal. You remember in math that change in y over change in x, or change in elevation over change in distance for earth science. Good. It asks for the gradient from D to C, and you actually just saw the math a second ago that the difference between D and C is 500 feet. You're saying, how do I get feet? Because the map scale at the bottom says miles. So then you just need to figure out the distance between the 2 points. And if you use the map scale, you'll be able to figure out that the distance is approximately 2 miles. 500 feet over 2 miles gives you a gradient of 250 feet per mile. Can I get it too easy? All right. List the 3 types of stress. I was looking for tensional stress, right? That's when you pull things apart, like stretching a rubber band, or at a divergent plate boundary, or at a normal fault. Shear stress, which you'd find at a transform fault or a strike slip fault. And compressional stress, which we know is going to be when the stress is pushing together. That would be at a thrust fault. That would be at a collision boundary or subduction boundary. Bigger term for that is the convergent plate boundary. And lastly, you would also find compression with folding. Now, redshift and its role in understanding the universe. Redshift is the Doppler effect and the idea that when objects are moving away, their wavelengths are being stretched or expanded. Hubble used this to prove that the universe was expanding. That's why it's important. Peer review, on the other hand, is very important because when you do an experiment, you need other people to validate your works. People need to critique what you're doing. Now, I'll tell you, in real research, peer review can be a little stressful because people want to figure out what you did wrong and they want to ridicule you because they're against change. However, you need that in order to validate your work. You need hundreds and thousands of people to take your research, your conclusion that you've now published for peer review, and they need to go through and follow your steps and see what you're saying. Very, very important. Alfred Wegener, he had his hypothesis for continental drift. Of course, he lacked a mechanism, which is why a lot of people didn't buy into his idea. Remember that he thought that the gravitational pull from the moon would move the plates. However, or the continents actually, I didn't even know about plates. However, that force would have stopped the Earth from rotating. All right, so on to his two fossils. That would be the Glossopteris, that was the seed fern, the plant. And then the Mesosaurus was the little reptilian. There was no way that reptilian was swimming all the way across from South America to Africa. Like, it just wasn't going to happen. So the continents must have been closer together. People like that part, by the way. They just didn't buy into the rest of it. And then contrast independent and dependent variable. So independent, you can manipulate. It's what you're going to change in the experiment. And dependent is what you're going to measure. That is going to be the outcome. So independent can be anything. You can break it up. You can change it. That's what makes it very different than dependent. Dependent is just the measured outcome. What did you get from the experiment? Great example was my baking the cookies that I gave you guys. I love that example. If you change just one variable in your recipe, and I always suggest changing the cook time, right? That's going to be my independent variable. My dependent variable is, what did the cookies taste like? What was the effect on the cookies? Were they still hard? Were they super soft? Were they gooey? Were they under? Think about all those different variables. Those are all the dependent variable.